Hello everyone, welcome to my channel Similarity. This is the fourth video of the matrices series, and in this video we will see some examples of the matrices. So the first example that we will see is how we can scale an object using matrix. Okay, so let me add a toy object here, and now we will create a attribute wrangle here. Then we will create a vector. Basically this is a vector along which we will scale our object. Okay, so let's call it scale as well. And now we will create a matrix. Basically this is an identity matrix and this matrix will be scaled. Okay, so for that we will use a scale function, and this function takes matrix and the vector as an input. So what happens here? So first we created a vector, a scale vector. This is the vector along which we will scale our object. Okay, and then we created an identity matrix. Then this identity matrix is given inside the scale function. This scale function basically scales this matrix using our vector. Okay, now when we multiply our points with this matrix, basically our points will be scaled. Okay, so let me set the scale to 1 here so that you can see the original object. And now when I scale along the x-axis, you can see our object is getting scaled. Okay, similarly you can scale in other axis as well. So this is how you can scale an object using matrix. Now let me show you one more thing here. Let's say I add a transform node here, and let me translate this object to some random location here, somewhere here. Okay, also let me reset this to 111. Now you will notice one thing. If I scale this object right now, you can see the scaling is still happening around this origin, or you can say the scale function basically considered the origin as the pivot point, not even the scale function. Even if you rotate an object using this matrix, basically the rotate function you have, that function also considered the origin as the main pivot point. Okay, so to resolve this issue, or you can say if I want to scale or rotate this object along its local center, or you can say the centroid of this object, what we can do here basically, uh, first what we do, let me first duplicate it also. Okay, so now what we can do here, first we will get the center of this object. Okay, so let's call it center, and for that we will use a get bbox center function. So this function basically provides us the centroid of this object. Okay, and now what we can do, basically first we will translate this object to the origin. Okay, so for that we will use a translate function, and we provide our matrix, and we use minus center. Okay, because we want to move back to the origin. So you can see, let me comment it out. Okay, so now you can see that our object is moved back to the origin here. Now we can scale our object, right? Let me scale it. So you can see basically we are scaling it around the origin here. And again, after the scaling is done, we will move it back again to the original position. So we'll copy it here, and this time we remove the minus sign. So that's how we can scale an object if it's if it is moved to some random location. So you can see here, now it is scale like it is scaling around the centroid. So let me move it somewhere here as well. See, it seems like it is scaling around its centroid. So that's how you can scale an object if it is already transformed. Now this is how scaling does, and now we will see how we can rotate an object. So let me create a tube here. Also, let me end caps here, and we can add some rows here. Also, we can increase the height. Now we will add a attribute angle. Okay, so to rotate an object, we need two things. We need the axis along which we want to rotate the object, and the second thing we need is the angle. How much, basically how much we want to rotate it. Okay, so first we'll create the axis here. And next we create a angle here. Also remember the angles will be in radians. Okay, so we will write radians here, and inside that we can write ch angle. Okay, also let me go inside the interface and set the range of our angle to 360 and set our axis to y, because along this axis we want to rotate our object. Now we can create the rotate function, and we can, okay, we haven't created our matrix yet, so first let's create our matrix. We call it mat ident, and now we provide our matrix inside the rotate function. And second thing it needs is the axis, I think. Okay, let me check here. Okay, it first it required the matrix, then the amount or the angle you can say, and then the axis. Okay, so matrix is already there, then we provide our angle and then the axis. And then we multiply our points with the matrix. And now you can see if I do it something here, you can see we can basically rotate our object. Okay, so this is a very basic function how you can rotate some object using matrices. Now let me show you one advanced thing, basically how we can what you say, like twist this object. Okay, so for that first we need one thing. First let me duplicate this here, and next thing we need a attribute adjust float here, and we have operation here, I believe, bounding box. Okay, set this to set initial, and we can call this gradient or grad. Okay, let's see what kind of attribute it gave us. So what this basically gave us, see all the points at the bottom, I believe has a value of 0. Okay, basically it is giving us vector. We don't need the vector. Okay, sorry, here. Okay, so what happens here? So using this attribute adjust float, we basically created an attribute called grad, or you can say, I mean, it's a short for gradation or gradient. I write it grade here, or you can give any name you want. So basically this grad attribute has a value that goes from 0 to 1. Okay, all the points at the bottom has a value of 0, and all the points at the top has a value of 1, and the points in the between has a value goes that corresponding goes from 0 to 1. Okay, it gradually changes from 0 to 1. Okay, you can also see here the value is gradually going from 1 for the top points and 0 for the bottom points. Okay, so basically we created a gradient here, or you can say in very easy language, basically I created a gradient here. So now what we can do here, we can plug this here, and we can multiply our angle with the gradient. And you can see, you can already see here now what is happening. See, the points which are at the top, is getting most rotation, or you can say it's getting the rotated, the amount that I've shown here. But the points at the bottom, doesn't receive any kind of rotation, and the points in between, receives the rotation amount gradually. The rotation amount changes gradually from bottom to top. The points at the bottom, no rotation. The points at the top receive the maximum rotation, and the points in between receives a gradual rotations. Okay, so we can basically create a twisting kind of effect here. Okay, let me change this to more. You can see we can basically twist this object. Okay, so also let me add a toy here. Let's see what would happen. Yeah, you can see a very cool example, right? So this is how we can basically create a twisting example using matrices. Okay, so this is it for this video, and these are some very basic examples of using matrices. We covered how we can scale an object if it is already transformed. Then we learned how we can rotate an object using matrices, and then finally we learned how we can twist an object using matrices. Okay, so these are some fundamental examples of using matrices based on the theory we have learned till now. There are other some very advanced examples as well, but I won't be showing this in this video because this is meant to be fundamental. There will be some more videos for the matrices in the future where I will show you some advanced examples as well. Okay, so this is it for this video, and if you like this video, please hit the like button, and if you like my content, please do subscribe my channel. I feel really motivated when you do that. Okay, so thank you for watching my video. Bye.